Hello students and welcome to this calculus video. In this video we're going to be learning how to solve differential equations and how they might come up in free response questions. So let's get started. So as you're looking through your handouts, through your papers, you're going to notice that this question from 2000, question number 6, comes up first. I'm actually not going to cover this in a video because you can pretty much look up all the free response questions and video formats and their solutions already online. So since that's already available, I'm going to jump over here to this next page where we're able to get started. So we know that the acceleration of a particle is given by a of t equals 6t minus 2. So we know the velocity is 25 when t equals 3. So I'm going to write down here that v of 3 equals 25. And the position is 10 when t equals 1. So since we're already have the position function here, then we're going to say, all right, x of 1 equals 10. So that's going to help us out. So since I want to go up, and I'm starting with acceleration, so I want to go up to velocity, and then I want to go up to position. All of that is tipping me off with integration. So in order to do this, so I know that v of t is going to be the integral of 6t minus 2 dt. So I'm going to write here that this comes out to be v of t equals 3t squared minus 2t plus c. And since I know what these are going to be equal to when t equals 3, this is going to be equal to 25. So 25 equals 3 times 3 squared minus 2 times 3 plus c. All right, so I have 3 squared, so that's 9. 9 times 3 is going to give me 27 minus 6 plus c. So 25 equals 27 minus 6 is 21. So 25 minus 21 is going to give me 4. So 4 equals c. So I know that v of t is going to be equal to 3t squared minus 2t plus 4. So again, I want to go out to position. So if I want to figure out what position is, well, x of t is going to be equal to the integral of the velocity, what I just found. So 3t squared minus 2t plus 4 dt. So let's go ahead and solve for this one. All right, so x of t is going to equal t cubed minus t squared plus 4t plus c. All right, so now I know, again, that x of 1 equals 10. So 10 equals 1 cubed minus 1 squared plus 4 times 1 plus c. 10 equals 1 minus 1 plus 4, so 4 plus c. And so I'm going to get 6 equal to c. So what is my actual position function? Well, let's write it out here. X of t is going to be equal to t cubed minus t squared plus 4t plus 6, which is answer choice C. And I do want to talk about a test-taking strategy in this particular problem, so that maybe you don't need to go as deep as you actually need to go. Because what I noticed here is I knew v of t was going to get me 3t squared minus 2t plus 4, right? So looking at this, I know when I take the integral, I'm going to end up with 4t here, no matter what. And I'm looking at my answers. The only answer that has 4t is answer choice C. So I never even had to do any of this work. Not that any of it is wrong, all right? But I could actually exclude all of this work in terms of a timed test, write the answer choice C, which is going to be correct because I know it, what the t is going to come out to be. And then I could just move on to the next question and bank some of that time. And so that's just a small test-taking strategy that you can keep in mind. So now let's move forward here, and this is going to be more of a free response question. So again, we have particles, we know what the acceleration is, and we know at time t equals 0, the velocity is -9 and its position is -27. So velocity, so that means v of 0 equals -9, and it means x of 0, keeping the same notation from the earlier part of this video, x of 0 equals -27. So we want to start by finding v of t, the velocity of the particle at any time t. So that means we want that exact solution where we have that c filled in. Okay, so in order to do this, I'm going to say, okay, v of t equals the integral 6t plus 6 dt. So we know that that is the acceleration. So let's find the integral. Well, this is going to be 3t squared plus 6t plus c. Substituting in the values that I know and what this is going to be equal to, so I know that this is going to be -9 equals 3 times 0 squared plus 6 times 0 plus c. So I know that -9 equals c. So I can say that v of t is going to be equal to 3t squared plus 6t minus 9. So very similar to what we've been doing in previous parts of this video. But it's a free response question, so we do need to combine other stuff. And that's going to come out here in part B. So here in part B, we want to find, okay, what is the net distance? So remember, the net distance is basically where that position ends up in relation to the original. So it doesn't take into account the total about any left and right turns, it just takes into account the final and the beginning position. So in order to find net distance, all you want to do is recall that this is going to be the integral from 0 to 2 of v of t dt. So no absolute value here. That's going to be for total distance. So net distance here is going to be the integral from 0 to 2 of, and we just found v of t, so 3t squared plus 6t minus 9. And then this is going to be equal to t cubed plus 3t squared minus 9t, evaluated from 0 to 2. So I don't really need to do the minus 0, so I'm going to show it here, that we get 2 cubed plus 3 times 2 squared minus 9 times 2 minus 0. That part, when I substitute 0 in all those values, it's just going to be plus and minus 0 all over the place. So let's figure out what this is. So this is going to get me 8 plus 3 times 9. That's going to be plus, 2 squared. So that's going to be 3 times 4, so plus 12 minus 18. So 8 plus 12 minus 18 is going to get me positive 2. So the net distance comes out to a positive 2 feet. In terms of particle, that means it ends up 2 centimeters, 2 feet, whatever, in relation to where it started. So now in part C here, what I want to do is something very similar. I want to find the total distance traveled. So the total distance is going to be equal to the integral from 0 to 2 of the absolute value of v of t dt. So how are we going to do work with the absolute value? Well, we need to figure out where v of t is changing directions. So all I do is set v of t equal to 0. And we've already solved for v of t. So 3t squared plus 6t minus 9 equals 0. So I can see that I can factor out 3 from all of these. So I get t squared plus 2t minus 3 equals 0. So let's factor this. I get t plus 3 times t minus 1 equals 0. So t equals either -3 or t equals 1. One thing that we have to keep in mind is that we're working with time. So we're not going to take into account this -3. We're only going to take into account this 1, and then we're going to combine where we're changing directions, making sure everything comes out to be positive. So our total distance is going to be equal to the integral from, so we're going from 0 to 2. So first one, I'm going to have 0 to 1 of v of t dt, and then I'm going to add it to the integral from 1 to 2 v of t dt. Now using a sign chart, let me do a sign chart real quick. If I put a 1 in here, let's figure out where we're going to have positive side and where we're going to have a negative side. So if I substitute in 0 in this case into the sign chart, I get 0 plus 3 and 0 minus 1, so this comes out to be negative. And if I substitute in 2 into the sign chart, I get positive times a positive. So this comes out to all be positive. All right, so I know that left of 1, in between 0 and 1, that this is all going to be negative. So this part, since this is negative, I want this entire integral to come out to be positive. So that's absolute value around there. So we've already calculated here, all right, what is the antiderivative? We know that that's t cubed plus 3t squared minus 9t. So I'm going to have the absolute value of t cubed plus 3t squared minus 9t. And we're going to evaluate this from 0 to 1. Plus, we're going here from 1 to 2, so I'm going to have t cubed plus 3t squared minus 9t evaluated from 1 to 2. So let's go ahead and do that real quick.
Crying on the dance floor, I'm a city
And so that is going to give us the total distance traveled from t equals 0 to t equals 2, how far this particle has moved. Notice here how everything starts to come into play. We are factoring, right? We're doing a lot of algebra steps, but taking the integral, going up steps, doesn't actually seem to be that complicated. In fact, sometimes it just isn't going to be that complicated. Just remember, everything is position, velocity, acceleration. If you want to go up, you're just integrating. And then from there, it's just applications of derivatives and stuff that we've done before. Notice how the connections to position, velocity, and acceleration are the exact same from what we learned in earlier modules. Of course, if you need any help with any of these problems, feel free to reach out to me. I'm Mr. Hernandez, and this is Mr. Hernandez Teaches.